Graphical representation of motion. Here we will learn the distance-time graphs. The first case is when a body is at rest. Now, suppose a body is stationary at a distance of 10 centimeters from the origin. So we take a point here, we call it the origin, say O, and you have a body at a distance 10 centimeters from the origin. At a point A. The position of the body does not change with time because the body is at rest. Its distance from the origin continues to be the same at all instances. Suppose you take 0 seconds, it will be 10 meters. Or centimeters. In this case we have taken centimeters. At 1 second it is 10 centimeter, at second also 10 centimeter, at third second 10 centimeter, fourth second 10 centimeter, fifth second 10 centimeter, because the body is at rest and it does not move. It is in that same position A. Let us draw the distance time graph of such a body. So here is the distance time graph. We take the time on the x-axis and the distance on the y-axis. Now we plot the first case, time 0, distance 10, and that would be at this point, time 0, distance 10. Now for the second, time 1, distance 10 again. So this is time 1, distance 10. So the point will be out here. Second case, time 2, distance 10. So we have time 2, distance 10. Now the point will be out here. For the next, we have time 3, distance 10. So time 3 and distance 10. Next, time 4, distance 10 again. So that point would be somewhere here. Next point would be again somewhere here. And now when you join all these points, you will get a straight line. So this will be a graph of a body at rest. The graph is parallel to the time axis, which is the x-axis. In case 2, we will learn about the graph when a body is in uniform motion. So here the values of time and distance in uniform motion have been given, and let's plot it on a graph. So here is the distance versus time. We take the time on the x-axis, so here is time in second, and distance on the y-axis in meters. The first observation, time 0, distance 0, and the point would be at the origin here. Next observation, time 1, distance 20. So we have time 1, distance 20. So it would be somewhere here. So this would be the next. Next we have time 2, distance 40. So time 2 and distance 40, it's here. So we mark the point time 2, distance 40. Next, time 3, distance 60. So we have time 3 and distance 60. So it's somewhere here. Next, time 4, distance 80. So time 4, distance 80. last time 5 seconds, distance 100, and that would be 5 seconds here, and the distance 100, so somewhere here. We'll now join the points. So here we get a straight line. This is a straight line. So here is the graph of uniform motion. And if you can recollect what is uniform motion, when a body covers equal distances in equal intervals of time. Body covers equal distance in equal intervals of time. So when a graph is a straight line, we have uniform motion. We now go to case 3, when a body is in non-uniform motion or accelerated motion. So when a body is in non-uniform or accelerated motion, here is the table, and let's plot the graph. So here is the distance time graph. The time is always taken on the x-axis. It is measured in second. Distance is taken on the y-axis. It is measured in meters. For the first point, time 0, distance 0. So that point would be out here. Next, time 1, distance 5. So time 1, distance 5. So here time 1, this would be distance 5. So the point would be somewhere out here. Next is time 3, distance 45. So time 3, distance 45 is, this is time 3. Distance 45 will be between 40 and 50, so it's somewhere here. Let's do time 2, distance 20. Time 2, distance 20. So time 2, distance 20, it meets out here. Next, time 4, distance 80. So 4 is here, 80 is here. So they meet out at this point. Next, 5 and 125. So time 5, 125 would be somewhere around here. Now if you see, it is not a straight line, but it is like this, a curved line. So this is non-uniform motion. Non-uniform motion, or we can call it accelerated motion, where a body covers unequal distances in equal intervals of time. So this is the graph of non-uniform motion. Distance time graph of non-uniform motion.